Welcome to Operations Analytics. I'm Dr. James Rowe from Roller College of Business at Rowan University. The topic of this lecture is Linear Programming Transportation Model. We will learn fundamental concepts of transportation model in this lecture. Look at the structure of this course. This lecture introduces transportation and network models to students. Last lecture provided examples of number of managerial problems that could be modeled using linear programming, and this chapter will provide even more such examples. However, all of the problems in this chapter can be modeled as networks as well as linear programs. The use of networks helps in visualizing and understanding the managerial problem. These models include the transportation problem, the transshipment problem, the assignment problem, and maximum flow problem, and the minimum spanning tree problem. The use of linear programming software will be the primary means of solving these problems in this module. However, to take advantage of the unique structure of some of these problems, specialized algorithms can be used. This is more complex and generalized form of linear programming. Transportation, assignment, and network models are widely used in business. In this lecture, we will see how those issues could be formulated and solved. Learning objectives. There are 4 learning objectives in this module. First, construct and solve linear programming for transportation problem, use of linear programming for facility location analysis, apply linear programming to assignment problem, and lastly, formulate linear programming for transshipment models. So those 4 things we want to look at one by one. First, the transportation problem. The basic transportation problem is concerned with finding the best, usually least cost way to distribute goods from sources such as factories to final destinations such as retail outlets. If there are intermediate points such as regional distribution centers where the items must go before being shipped to the final destination, then the transportation problem becomes a transshipment problem. The assignment problem involves finding the best, usually least cost way to assign individuals or pieces of equipment to projects or jobs on a one-to-one basis. In other words, each person is assigned to only one job, and each job only needs one person assigned to it. The company that we want to look at is Executive Furniture Corporation. Look at this diagram, network diagram. We have source. There are 3 sources such as Evansville and Fort Lauderdale, and there are 3 destinations. Boston and Cleveland are included here, and there are the supply 100, 300, 300. It could be cargoes or shipments. They can be supplied here in these cities to the destinations in the United States. And the demand from these cities are 300, 200, and 200 shipments or cargoes or containers. The decisions to be made involve the number of units to ship on each route, so there is one decision variable for each arc in the network. So this is node, and these arrows are called arc. In this problem, transportation problem, we want to minimize the transaction cost. We want to meet the demand in a timely manner, and we do not want to exceed supply because that's not going to be met or cause some kind of expedite orders. So let's define Xij equals number of units shipped from source I to destination J, where I equals 1 to 3, or 1 is Des Moines, and 2 is Evansville, and 3 is Fort Lauderdale. So these 1 to 3 are represented by I, so the origin, and J is the destination. 1, 2, 3 means Albuquerque and Boston and Cleveland. So these are three destinations, and it's identify Xij. I is again origin, J is the destination. Then our task is first to formulate the objective function, and the objective function is to minimize total cost. And the cost is defined by the cost to ship anything to the destination, and this takes some research for you to find it out. But in this case, say all research has been done and we found $5 from source 1 to source 1, that's $5, and $4 to the next destination, and $3 for Cleveland. In the same way, from Evansville to destination 1, it takes $8, and then $4 and $3. And lastly, the third one, $9, $3, $7 and $5. So that transportation cost is given there, and we want to put it into the minimization function. And we have now constraints. So these are quite straightforward constraints that we are going to look at. The first one is supply constraint for the first city, Des Moines, and that's shipment from this place to the first destination, second destination, and third destination cannot exceed 100. It should be less than equal to 100. That's what it means by x11 plus x12, x13 has to be less than 100. Similarly, the second one, the supply is 300. The things that you are shipping from Evansville cannot exceed 300, and that shipment can go to three destinations: x21, the first city, second city, and third city. x1, 2, 1, 2, 2, 2, 3. In the same way, Fort Lauderdale, the supply is only 300, and the shipment can go to the three places, and they cannot exceed 300. So x31, 3.2 and 3.3 has to be less than or equal to 300. Now let us look at the demand. Demand has to be met. It cannot be neglected at all. So we realize that for Albuquerque, its demand is 300, and the shipment can be received from three places. For example, Des Moines or Evansville or Fort Lauderdale. These are three places you can receive the order. 1, 2, 3, right? That's the three places that you are receiving your orders, and they are, if you look at that, the destination is 1, right? 1, meaning the destination is the first city, and the source place could be 3, 1, 2, 3. So 1, 1, 2, 1, and 3, 1, meaning this place, that place, and third place can bring a shipment to you. So that's limited to 300, and it has to be equal to 300. And in the same way, Boston, three places you receive the order, so the destination is fixed. However, the source city are changing 1, 2, 3, and that's 200. And then the same way for the third place, Cleveland, the destination is fixed and the source city is changing, and it has to be 200. That's met here, and that's how you are setting up your constraints. And of course, we are going to include this non-negativity constraint because we don't have any negative number in real life. And if you have done that, now you are ready to run your analysis using Excel. And this is a just quick result of the Excel, and I'm going to show you and walk through it with you shortly.